Hello everyone and welcome back to Express Academy. In today's video, we're diving deeper into 101 module where we explore fascinating world of determining and configuring hardware settings. In the first part, we explored BIOS, hardware, connection types, proc and sys directories. Now let's dive into the remaining topics. Let's start with UDEV. Picture the kernel as the brain of your operating system, responsible for addressing and interacting with the hardware. Enter UDEV located in /dev directory. It's an unsung hero ensuring your hardware seamlessly communicates with the kernel. In simple terms, UDEV is a Linux subsystem that handles device events. When you plug in devices like network cards, external hard drives, mouse and keyboards, or even joystick and gamepads, UDEV detects these events, making it a valuable utility. It acts as a guardian for dev directory, managing device nodes and allowing you to control device assignments. And here's the magic. UDEV lets you control what each device will be in dev directory. For example, if you want to use a flash drive for backup, you can use rules to assign a specific file in dev directory to your flash drive, ensuring it's always dev/mybackup whenever connected. In essence, UDEV serves as the keeper of the dev directory, abstracting device representation, regardless of the manufacturer, models, or underlying technologies. If a program wants to read or write from or to a device, it will use the corresponding file in dev directory to do so. This can be done on character devices or block devices. When listing A, B, C will indicate this. B character represents a block device such as disk drive. C represents a character device such as a terminal or printer or a special device such as null. D represents a directory. And L represents a symbolic link to another directory of file, either in dev, proc, or run directory. Now let's talk about dbus, a magical message bus system that simplifies communication between applications. Beyond its wonders, dbus reads information from the dev directory, connecting it with the user. Consider dbus as a helper that saves programs from dealing with the complexities of the dev and sys directory. Another perspective on dbus is an inter-process communication system (IPC), enabling communication between processes on the same or different systems. It provides a straightforward, standard, and secure channel for data and command exchange, eliminating the need for complex mechanisms like sockets or pipes. Now let's check out some ls utilities that show more information about the hardware which has been attached to our system. The ls-usb command allows you to display information about USB devices and bus lines that are attached to them. To use this command, just type in ls-usb in your terminal. As you can see, the list shows you all the device and buses that are connected to your system. You can use the command with T option that displays information in a tree layout. And V option is for verbose output, which gives you more information about each device. There is also a USB view command that you can use to view USB information graphically. The data is presented in the tree view in the left pane. Selecting an entry shows the detail in the right pane. The second ls utility that we are going to talk about is LSPCI. LSPCI is a utility for displaying information about PCI buses in the system and devices connected to them. By default, it shows a brief list of devices. You can see all the LSPCI options or switches with --help. Remember, you can do this for most of the commands in Linux. Again, the T option will display the output in tree format with information about bus and how devices are connected with those buses. The output will be only using the numerical IDs. LSPCI has a very helpful switch to know the name of the kernel module that will be handling the operation of a particular device. And just like ls-usb, -v option will give you more verbose output. Or you can use -tv for verbose info in tree format. The third ls utility is lsmod. lsmod is a very simple program with no option. It nicely formats the content of the file proc modules or lib modules, which contain information about the status of all the currently loaded Linux kernel modules, LKMS. Try cat/proc/modules and compare the results. As I told you, cat command shows the contents of a file. These are the kernel modules that are currently loaded. Use modinfo to get more information about a module if you want. If you need to add a module to your kernel or remove it, you can use rmmod or modprop for it. Let's do two more ls utility and close this session. lshw is a small tool to extract detailed information on a hardware configuration of a machine. It can report exact memory configuration, firmware version, motherboard configuration, CPU version and speed, cache configuration, bus speed, and etc. And the last ls utility is lsblk. lsblk or lsblock shows information about all or specific block devices. lsblk command reads the sysfs file system to gather information. The command prints all the block devices in the tree-like format by default. Use lsblk-help to get a list of available columns. Just remember, many Linux distributions do not have lsblk command pre-installed. And that's it for this module. Hope you enjoyed it, and if you do, please subscribe and recommend this channel to your friends.